Hello guys, in this tutorial we will design a module that will display a single bit digit using a 7 segment display. We are going to create this design using VHDL, and if you are using Notepad++ for designing, then select VHDL from the language option here. To start with the designing, we first have to mention the libraries that we are going to use in our design. We will use the IEEE library, and from this library we will use the standard logic 1164 package. This package is used for describing digital logic and vector in VHDL. VHDL design consists of an entity and its architecture. We have to define the entity first. Once the entity is created, now we have to save this file with the same name as the entity name. The input and output of the entity are defined in the port statement. This entity will have one input and one output. The input to this entity is the BCD numbers. Since the BCD numbers are 4-bit long, we have to use the standard logic vector, which is 4-bit long. The output of the entity will directly go to the 7-segment display. Since there are 7 LEDs in the display, we have to define an output vector which is 7-bit long. Now that we have defined the entity, we have to define its architecture. There are various styles in which we can design the architecture of the entity. In this tutorial, we will use behavioral modeling. To define an architecture, we will use the keyword architecture. After that, we will define the name of the architecture. The name of the entity must be specified for which the architecture belongs. To start the architecture, we have to use the begin keyword. Inside the architecture, we will use a process statement. A process statement is a key structure in behavioral modeling. The process can be written in a variety of ways. The most common approach when using the process statement for describing a design is to use a form that has a sensitivity list. A sensitivity list contains a signal that causes the process statement to execute if there is a change in the values of that particular signal. So in other words, we can say that the process is sensitive to that signal. In our case, that signal is the BCD numbers. So whenever there is a change in the BCD number value, the process statement gets executed. So inside this bracket, we have to define the sensitivity list, that is the BCD number. This is how we define a process in VHDL. Inside this process statement, we have to assign the values to display LEDs corresponding to the input that we get from the BCD numbers. In the truth table from the documentation, we can see that the BCD value have to take 10 different values to represent a particular number on the 7 segment display. For example, to display the number 0, the BCD number should take the value 0000, and we have to assign these particular values to the 7 display LEDs. We can do this by using a case structure in VHDL. This case structure will have 10 different conditions and one default condition. The case structure is defined as follows. Inside the case statement, we can define the condition using the when keyword. This means that when the BCD value gets the number 0000, we will assign the display LEDs as follows. This value we can get from the truth table. Similarly, we can define 9 other conditions from the truth table in the similar way, and one default condition where the BCD value exceeds with the number 9. Now we will define the default condition. This default condition is useful when the BCD number exceeds the number 9. And when this condition arrives, we can assign a 0 value to the display LEDs. This means that the display 7 segment display will not turn on. Now we have completed the module for designing the 7 segment display with which can represent the digit from 0 to 9. Now that we have created a VHDL module that will display the digits 0 to 9 on a 7 segment display, we need to create a testbench file that can test our design. This module is also designed using VHDL. We will include the same libraries that we have included in our previous module. The testbench file also has an architecture and an entity. We will define the entity first. The test bench file will not have any types of input and output, so we will not define the port. We will directly define the architecture. We will name this architecture as behavioral for our 7 segment display test bench file. Before proceeding, we must save our test bench file with the same entity name. As we are writing this test bench file to test our previous module, we have to include this module in our current file. We can include that file using the component keyword. We can include the module using the component keyword as follows. Whenever we want to use this particular module in our current design, we will use the component initiation method. This method will be discussed further. Now we will define signals that are going to be used in our architecture. These signals are used to connect the input and output of this module with our current design. Because we have not defined any input and output in our current test bench file, these signals are necessary. These signals are going to be restricted only till the architecture and not to the entity. This signal will be of the same size as that of these input. Now we will begin with the architecture with the begin keyword. Now we will initialize this particular component in our design. Like in higher level languages, we call a function. In VHDL, we can call a component, and this process is known as component initialization. Also, this particular component is under testing. We can also call it as unit under test. We can give this particular name according to our wish. I have given this name as UUT. In component initialization, we have to map the port of this module with the signal that we have created. Now we will define a process which will give the test cases for the BCD numbers. We can also name the process as follows. I have given the name as the stimulus process. In this process, we will provide all the necessary values that the BCD number can take up, that is from 0 to 9. We will also provide some extra condition in which the display LED should not turn on. After providing each condition, we will wait for 100 nanosecond. All these conditions will now represent the BCD number from 0 to 9. Now we will provide extra conditions. In these three conditions, the display LED's values should all be zeros. This wait keyword will be used to stop the simulation. Now our test bench file is ready.